Okay. And this might sound kind of silly, but everybody is fully aware that you don't have to do every homework problem in each section. You only have to do what's on the homework sheet. Okay, so I still have a few people like doing every problem. Like, that's great, you get lots of practice, but you don't have to. Yeah.
You don't have to do if you don't want to. You want me to remind you about that?
Oh, that's right. Let's do that first. Let me think. So, where did I get that from? Okay. Stole it from somebody. Shoot, I had an example I made, but now I gotta, okay, let me think. So if I have, for example, if I have this, we're gonna do something very strange. So prepare themselves. Does everybody agree that this is x squared? Okay. Would everybody agree that this is 6x? Because how long is this side from what I've drawn here? Yes. Is everybody with me? So this is a visual way to think about this expression. What's the total area here? What's the area of this rectangle? 6x. So what's the total area here? X squared plus 6x. Beautiful. You guys with me? So that is a visual representation of this expression. Something you don't get to see too often. Okay. I was about to go off on the whole thing, but I won't. Now, can somebody, let's do it this way. Well, let's do it, I'm trying to think about which way to do this. If I cut this sucker in half, what do I get, of course? 3, 3, yes? So I'm going to kind of redraw this. I'm going to redraw this. So I have x, x, and then I have 3, 3, yes? Now I should have drawn them skinnier, but too bad for me. Is everybody with me? Is everybody cool that the total area here is the same as the area there? Because all I did was chop this in half and put half here and half there. Is everybody with me? Does this, if I put those together, if I like staple all this stuff together, dadgummit, it's supposed to be a square. All right, let me try this. This is my x by x square. If I staple this 3 and this 3, so this is my x, this is my 3, this is my x, this is my 3. Is that visually a complete square? What would it take in order for me to complete the square?
Filling 3 times 3.
Do you guys see that? I would have to have a little square down here that's how long? How long would it have to be to fill in this little missing gap? It would have to be 3 long by 3 wide. So the thing I'm missing to complete this square is 9. Now remind me, is everybody with me? You can see the visual. If I put all these parts together, it's not making a complete square. If I add a little square of 9, now it's a complete square, yes? So up here, remind me, what's the steps for completing the square? What do I do with this? What do I do with 6? What's the 2 steps to complete the square?
Divide 6x.
Divide 6 by, cut 6 in half. Take what I get and do what?
Square.
Divide 6 in half. Yes, divide 6 in half. Take what I got and square it. Do you guys see? So this is the visual analogy to what we do algebraically. If I add 9 here, now I've got, what, does anyone know what the area of the square is? Don't overthink that 9. This little piece is 9, but how long is this side? How long is this side total?
X plus 3.
And how long is that side total?
X plus 3.
So what's the area? X plus 3 times x plus 3 is x plus 3 squared, yes?
Yeah.
Okay, maybe. Now listen, just make sure you guys understand. Do you ever have to do this yourself? No.
Yeah.
This is a visualization of the process of completing the square. And the really cool thing is, maybe this will stick in your head, this visual, that plus 9 is literally the thing we need to complete the square. Which kind of helps explain why we call it that. Okay. You can thank Christine. Christine reminded me that this is a thing I could show you. So maybe if this sucks, if you hated what I just did, forget about it. As long as you can do this, this is what you're going to have to be able to do. Okay. So let's do a slightly worse algebraic example. So what if I had this here? Sure. Yeah, what's the first step? What do I have to do? Because completing a square is hardwired on something that's not true here. What do I have to do first?
Make A.
I have to make this first number a 1, yes. Completing the square is hardwired on this being a 1. So of course the way I make this a 1 is to do what to everything? Divide by 2. Die. So I get x squared minus 6x equals 7/2. So what kills me is some students, I'm sure right now, did anyone feel a little twinge inside because the 7/2 is sitting there? No? 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 Good. Sweet. I'll stop assuming things. Good. Maybe you guys remember because we don't have to do much with it. It's just sitting there staring at us. We're going to stare right back at it and say, what you got? So how do I figure out where to go from here? How do I figure out what has to go here?
-6.
Yes, so the 2 steps are whatever's in the middle, the coefficient, you cut it in half, and then you do what to that? Square. Why do we do those 2 steps? Because of all the shit we did yesterday on the boards. We just noticed the number inside, double it to get the middle. So if I know the middle, I cut it in half to figure out the number that's inside. And whatever number is inside, you square it, that's the last number. So I square it to get the freaking last number. So it's just us noticing a pattern and making a process out of it, which is basically the tagline of mathematics. Mathematics, noticing a pattern, making a process out of it. So if I add 9 to both sides, how does this factor? No thought involved, really.
X minus 3 squared.
And this is the most I have to do with the fractions. How do I add those together?
18 with 2.
Yes. You need to multiply top and bottom by 2. 18 plus 7 is 18 plus 7 is
25.
don't make a freaking decimal. Because now what can I do? What's the whole purpose of this? Why the shit did we do any of this? What can I do now? Square root. I can kill that stupid square and my x can be free. Die. Die. I just put a square root. What should I put? Plus or minus. You got to make that second nature. If you put a square root in an equation that wasn't there before, you got to put a plus or minus. What's the square root of 25? 5. What's the square root of 2? I don't know. Okay. I can't remember if I've shown you guys how to rationalize something. I think so. So one quick little side quest. We're going to go on a little side quest. Do you all agree radical numbers, like square root of 7, square root of 2, they're kind of gross? You all agree? Right, I think they're kind of cute, but they are relatively gross compared to like 3. Okay. What's even worse is when I'm divided by such a gross number. So most of the time, when I have a radical on the bottom, oh want to do something that will make the bottom not irrational anymore. Why can't I do the square root of 2? Why can't I not do this? Why can I do the square root of 9? Why can we do that? What is the square root of 9? So we could do it. Why are we able to do the square root of 9 easy? Because 9 already has 2 3's in it, yes? Yeah. Every number I can do the square root of, square root of 25 is 5 because 25 had 2 5's. So why can I not do the square root of 2? How many 2's are in there? This is 1 2, yeah? If only that poor little dude had one more 2. I really need you guys to look at me. Square root of 25 is easy, it's 5. But square root of 5, if it only had one more 5, it would be the square root of 25, which is beautiful. So here's what we do. If I multiply top and bottom of this by another rad 2, what does the bottom become?
2.
Yeah. Let's see if I can use the space appropriate. Here we go. So the top's just 5 times rad 2. Now here, square root of 2 times square root of 2 is square root of 4, which is 2. So an even better way to look at that is square root of 2 is half of 2, multiplicatively. So if I multiply half of 2 with half of 2, it makes a whole 2. Oh. So whenever I do like square root of 11 times square root of 11, that's 11. Square root of m times square root of m, that's m. Because half of something times half of something is the whole thing. So on the bottom, sure enough, I get 2. And what's the last step here?
Add 3.
Add 3. And I normally shove that 3 in front, just so the plus or minus is in the middle. That looks a lot better. Okay. So that was kind of gross. Yes? That was a little bit gross. Not too bad. We didn't have to do a ton with the fractions. We just had to get LCD. So they can sit there all day long as I don't have to do much with them. So what we're about to do, you're going to be very excited about. I'm going to use completing the square to solve this. And you're going to help me. So what I just wrote every possible equation involving a quadratic. A, B, and C could be anything. A can't be 0 or else it becomes not a quadratic. Is that cool? So is everybody cool with I can't let A be 0? Otherwise it would just be a line in comparison. So if I want to use complete square, so everybody just let go of the fact that there's no numbers up here. There's not even a 2, because that just means there's 2 x's. What do you do first? Same thing we just did. You don't want to do it, but what do we do? Well, it has to be true before I can do complete the square. First number has to be 1. So what do I have to divide by?
By 8.
I have to divide by 8. Now just to remind you guys, we are deriving something you never, unless I ask for like a bonus question, you never have to do this yourself. So how do you feel about these fractions? So we call 0 divided by a 0. If I want to complete the square, what do I first need to do? There's something in my way. I want to get him out of my way. You can do it, you can do it, you can do it. I need some space, because of course, what's completing the square? I cut the thing in half and a square, and then I add it.
C.
So what's in my way? The C over A. Yeah. So if I move this dude over, make some room. So every step we're doing is the same step we did on some problems yesterday. It just looks worse. Now I'm ready to complete the square. How do you complete the square? What's the first step? Half of the what's in the where? Half of what? And whenever this is already a fraction, I don't divide this by 2. I literally multiply it by 1/2. And what's 1/2 times b over a?
1/2 B.
So b over, 1 times b is b, 2 times a is, there you go. You just multiply straight across, right? I don't want to make a giant fraction. I don't want to make like a Voltron of fractions, yes? I just want, instead of divided by 2, I multiply by 1/2. And again, the process doesn't care. The process doesn't care. We care. The process doesn't care. What does the process say to do with this thing?
Square.
Square. And what's b over 2 squared? What's b squared? Holy shit, b squared. What's 2a squared? 4a squared. Yes. Okay. Let me stop for a minute. If you know quadratic formula, does anything look familiar yet?
Yeah.
A little bit? A little bit. Here, next couple steps, you're going to see it all coming out. What do I do with what here? I love that question. What's the first thing I want to do something with?
Add B squared.
Yes, the second thing I get is what I add. And the first thing I get is how it's going to factor. So I'm going to add this to both sides. And then look at this. Again, if I gave this to you in a test or a quiz and said factor, you are allowed to come up and slap me. Just right in the face, open palm. You can even do like they do with those competitions. You ready? But in this context, you don't have to think at all, do you? Does anyone remember? How do you factor this thing? How do you factor it?
X plus 1/2.
This, yeah. Whatever your first step is how this factors. Always. Okay. Remember that, because the uglier the stuff gets that you're working with, the more important it is to remember that. I don't have to actually factor it. I just have to put that in. How do I simplify the other side? What am I doing on this side? I have two what's? Two fractions that are trying to add. And why can't I just add them? They don't have, like, denominator. So ready with me? The one that has a lot on the bottom, what does it have? It has a factor of, you can do it. The one that has a lot on the bottom, what does it have? It has a factor of 4, and it's got a couple A's, yes? A times A. So what does he need to be the same as him?
4A.
He needs a 4, and he needs one more A. You guys see that? Do you see how that was not hard? It literally is just, look at one, what does the other one need, or what do they both need so they both become the same? He's got a 4, he don't. I'm going to give him a 4. He's got 2 A's, he only got 1. I'm going to give him another A. Poor little dude. Okay. So if I multiply this guy by 4A, top and bottom. On the top I get, is this cool if I do this because this is negative? B squared minus 4AC on the top? Does that sound familiar? All over 4A squared, right? Is this starting to look familiar? Sorry. All right, now what do I do to both sides? Square root. Since I'm square rooting, I have to put, right here I have to put what? Plus or minus. These kill each other. So the square root of b squared minus 4ac, I have no freaking idea. But what's the square root of 4a squared? What's the square root of 4?
2.
2, and what's the square root of a squared? Good. And what's the last step to get x by itself?
Add,
No.
subtract,
Subtract
which is good, right?
b over 2a. Do you see how they already have LCD? So x equals negative b plus or minus the square root of a squared by 4ac all over 2. That should sound hopefully familiar. So again, you never have to do this, but I at least once, anything we're going to use, you're going to see at least once where the hell it came from. It's not just shit we made up. We didn't go, yeah, let's make the p squared on the inside. That'll mess people up. No, it's just the way it worked out. Okay, so real quick, how do I use this? Let's look back at this problem that we did. We already know what the answer is supposed to be. So everybody got that written down? If you don't currently have this memorized, you need it memorized. Just because I want to torture you. So if I have this equation, and by the way, I really need to make this really in your face. We got quadratic formula from this equation. So what is quadratic formula's whole purpose of existing? Solving quadratic equations that are equal to 0. Yes. That's the whole reason it exists. That's what it does. So will it work here? Will it work here?
Yeah.
Do I have a quadratic? Is it equal to 0? Yes. Can you identify what A, B, and C are?
A equals 1.
Yeah, it's all the coefficients, right? 1, negative 6, 11. Kick ass. So now, just to write it one more time, can you guys go ahead and populate this thing with those values? Go ahead and try to throw them in there. Try to simplify. I'll catch up to you. So B is negative 6. This is one quick mistake people make sometimes. So it's going to be negative 6. Give or take. Another mistake I see is this. I've made a mistake. Can anyone see what mistake I've made? Or am I just insane? I'm not done writing it, so don't tell me I forgot the 2a. I'll put the 2a down here. What mistake have I made? I've made a mistake.
Put 6 in the parentheses.
Yeah, currently I'm squaring 6 with a negative. So people will write negative 36 here because maybe they throw this in the calculator. B squared, am I ever going to give you complex numbers to put? No. So what does B squared have to be? It has to be at least 0, right? It can't be negative.
Yeah.
So I'm not squaring 6 and putting a negative on it. I'm squaring negative 6. Okay, so be careful. Ooh, I made it. Wait a minute. Oh, man, Jeff. All right, do me one favor. I'm sorry. Do you see what I did?
Yeah.
It should be minus 11. Okay. It's not going to change too much. So make this a minus 11, which will make this a minus 11. Is that cool? What I just did was I looked ahead and I realized what I had written down was going to become imaginary, and we didn't get an imaginary answer. Now you can get imaginary answers, but I want this to match up. So what can you do inside the radical there? Obviously this is 6. What do you get?
36.
36.
Plus 3.
Minus and negative is plus. 4 times 11 is 44, all over 2. The next level mistake I see is somebody will make this a 3, and this goes away, but what's being divided by 2?
6.
this, and this. So you can't just divide one of them and have two go away. That's not fair. This guy should also get cut in half. So what's 36 plus 44? Can I simplify this?
Great, split it up.
And I'll help you out a little bit. 4 goes into it, yes? Times 20, but doesn't 4 go into 20 also? So 16 goes into 80 5 times. So whenever you try to reduce a radical, you try to break it up into the biggest square you can use. 4 goes in, but then 4 goes in again. 4 goes in 20 times, 4 goes into 25 times, so 16 goes into 85 times. So this would be 16 times 5. What's the square root of 16? 4. What's the square root of 5? I don't know. What's 6 divided by 2? 3. What's 4 divided by 2? Is that the same answer we got before? Yeah, yay! Alright. Interesting time. Somebody with me? Do you guys remember using quadratic formula at any point in your entire life? Besides, like right now. Does this sound familiar to anybody? Okay. Very exciting. I know, so I'm very happy you guys are staying calm. But it's just a bunch of plug and chug, yes?
Yeah.
Okay. So, does anybody need to borrow a calculator? You need a calculator for this. Anyone need to borrow a calculator? Come on up, I know what to do. Bring me something of value. Your ID, your keys, your phone, your very soul. No, not your soul. I don't know what to do with those. If you forget them, I don't know. Walk around with
Tear it
them.
off.
Huh? I can do what?
I don't know, tear it off.
Oh, the solar, there you go. I'm waiting for my smart asses, and I love it. I have a special place mark, because that was me. I'm a smart ass, so. Okay, everybody's got a calculator, yes? So let me do this. I'm gonna give you this sheet, and I really do want, I'm gonna show you one thing that'll get you started with it. Try to think about if I want you doing this by yourself or with others.
Make it.
What's up?
Split it up.
Do it again.
Like a couple by ourselves and then.
Maybe. Hold on. I think groups will be good. Yeah, let's do groups. Yeah. Okay. So we just finished section 2.5. Oh, before I forget, we're supposed to do 2.6 next. I've decided to push 2.6 off to the future at some point. I haven't decided where to shove it yet. So we will be coming back to 2.6. Or for the moment, the other sections are a little more important. They kind of go together a little more. So let me do this first. Everybody, let's just get everybody set, and then I'll get you in groups. Get everybody, turn your calculators on. Go to y equals, make sure it's clear. Why aren't you clearing? Go away. Okay. Why aren't you changing? Weird. Okay. You're having a good day. Now do this. Do you see where it says window? We played with these windows before, I think, maybe? I can't remember. Yeah, we've come in here before, right? Actually, do this for me. Everybody hit zoom 6, and you should get like a blank graph because nobody should have anything. Yes, everybody hit zoom 6. Is everybody with me? Now go back to window, and for the purposes of today, make x min -5, x, oh Jesus, Jeff, you used the wrong negative. Negative is down here, -5. X max 5, make y min -5, and make y max 5. Is everybody cool? You guys with me? So I want -5 to 5, Negative 5 to 5. It's going to make it easier to see some stuff. Okay, now let me put you into groups. Actually, let's do this one thing together. Is everybody cool with this? Go ahead and hit y equals, and put in here the square root of x. Okay. Nothing happened. Hold on. Put in here the square root. Oh, I see. The square root of x. There we go. I want to point something out. This is going to help you with this paper. Do you see how right now I'm inside the square root? If I wanted to put plus 1 inside the square root, I would just hit plus 1. If I wanted to put plus 1 outside the square root, I would have to hit the over arrow first to get out of the radical, and then put plus 1. Is everybody with me? So if I just put plus 1 right now, it's inside the radical. If I hit the over arrow, then put plus 1, it's outside the radical. Those are very different situations, yes? So with the square root of x, hit graph, and I just want to make sure everybody's cool with this. Does everybody get this? This will help me make sure everybody's got everything set correctly. Does everybody get that picture? Okay. So let's put you in some groups. Let me see. 2, 4, 6, 8, 10, 12. Look at you guys. Holy shit. Let's do groups of, I don't know, 4? Sure, we could do that. Why don't you two come over there, you 4 work together. You 4 work together. You can turn. And then you 4 come up this way. You guys, you 4 come over here. Get together. Okay. And just try to do as much as you can. If your group needs some help, call Christina or I over. Yeah, over there. Yeah. There we go. Cool. Let me know if you need help. Just try to do what this thing says. And you know, you've got 4 people. You maybe can divvy up the work. Yeah. Hint, hint, hint. Did you get a sheet? Just to change things up, work with it. Yeah. So now you guys have 5. Yes. This is one big group, but they're all facing away from each other. Maybe y'all can turn like, yes, work together. Maybe assign different people. There we got one more person in the other. Holy shit. Use them. Yes.
So, since it says Y2, you want us to like have...
Leave Y1, yeah, leave the radix in there. Yeah.
So then you want us to have
Each
like,
one you're
two
gonna
lines.
replace it, yeah.
Yeah,
Good.
Well,
We just have one thing to look at.
Yeah, so we're gonna have just one line on the ground, or do you want us to sketch both?
So leave this in there. Leave radix in there. And Y2, you're gonna make it this.
Yeah.
So then you can compare easier.
Yes, so then it would be like this. With like something like this, right?
Yes. Cool.
Oh.
Leave,
Do you want us to specify like how far this is?
leave this in there. That's why I was saying Y1 and Y2. So leave the radix in there. And then put the radix. Yeah, just to make it more visually so you can compare. And then, I'm sorry, what's your question?
The question is, like, how do you want us to lay out how far is that?
Yeah, the fact that we left is a huge thing. And then how many steps left, and you can see it a lot easier now. Yeah. So it looks like the entire graph just got moved. You can tell me how many steps left. That's the idea, exactly. Which direction did it go? Or what did it do? And how far? just to throw an idea, you can get, say, one person does number 2, one person does number 3, and then you confer afterwards, or you could all do them all. It's up to you. Yep. And then when you go to put this in, see how it says y2? Yeah. So you leave y1 alone. Yeah, good. So then you can compare it. Be careful, that won't be a shift. These two won't be shifts.
Yeah. This, just go down.
These
On the y-axis, not sure.
no. I should have made that a way to do it. Alright. Compare answers if you're all doing all of them for some crazy reason. Maybe make sure you get the same stuff. Make sure everybody's got the idea. Help anybody that needs help. All right, guys, I'm gonna catch up to you here. What did y'all determine? So, of course, the square root of x looks like this. Weehaw! What? And I really didn't mean to like sketch it. I mean, if you wanted to sketch it, you're fine. But when you graph it on your calculator, what did you notice happen here? It took this picture and it did what to it? What did it do? Yeah, it physically, like somebody reached in, the hand of math god reached in and picked this up and moved it back 4, yes? This whole shape just ended up going back here. So it went to the left 4. So if you wanted, it would be 1, 2, 3, 4, like that. Yeehaw! Just to make a rough sketch. Okay. By the way, if the point of the problem is to graph something, this is not good. But this is just a rough idea what happened. What happens here? What do you guys get for this one? Yeah, it went right 1. What it should have done is start at 1 now. So basically this whole thing just moved up 1, just moved to the right 1. How we doing? Did everybody get that? So just to show you, hopefully, if I put in here square root of x minus 1, Jeff. Why is this calculator doing that? X minus 1. It just moves right 1. And of course, it's kind of neat to have the one with all the colors, but if you don't, you're fine. Okay, just not as special as me. No. So, what happens on this one? Up 2. If you graph it, it should start here now, and then repeat the same shape. The same shape, it just literally went up 2. And why does that make sense? Because here's the old graph, right? Isn't that the original equation? And whatever the outputs were, I just add 2 to each one. So that makes immediate sense. That's just going up too. Kabam. So it makes sense then what you got. Well, no, that's the only one I did because it makes sense. Eventually we'll get here. What about this one? What happened with this one? Yeah. Good. You could say flip. You could say reflect. So reflected around what? What was the mirror? X-axis. So if the original was here, this would be down here. Yes? Would you say that flipped up and down, or did it flip left and right? Up and down. Does everybody see what I mean by that? So this totally flipped up and down. Yes? Whatever was up is down, whatever's down is up. Just had no downs, so now it's all down. Hopefully it made sense what I just. What does this do? Yeah, it flips it how now? Reflected around the y-axis. So it flipped it left and right, yes? So, let me start to make some generalizations. Would you say that 4 is inside with the x? Yes. Would you say that 2 is inside with the x? No, that 2 is outside, correct. So, I need you, this is so cool, because at first blush it feels like a lot of shit to memorize. No. If it's in with the x, it seems to do the opposite of what it looks like. Didn't this go back 4, even though it says plus 4? Now, let's analyze that for a minute. When you plug a number into this function, what's the first thing this function does to it? Whatever number you plug in, what's the first thing it does? You can do plug a 1 in. How do you do it? Plug a 1 in. What do you do? Plus 4. So whatever number I pick, the first thing this thing does is adds 4 to it. Is everybody with me? So if I put a 5 in, what do I do first? 5 plus 4 is, and then I take the square root, correct? So the first thing this stupid function does is it adds 4. Therefore, all my inputs can be 4 less than they used to be, because the first thing it's going to do is give me 4. So what was the smallest x we could put in originally? What's the smallest x I could put in to stay real? 0. But now I could put -4 in. So here's an example. Let's say it costs $6 cover charge to get into a club. And you're going there, but you know there's a very specific mugger outside the club, and they take $4 from you. Or, I'm sorry, let me turn that around. There, in this case, there's a really nice person that just won the lottery, and they're giving people $4. You with me? $4 for you, $4 for you. You with me? I just want to get in the club because my friends are in there and they owe me drinks, so they're going to pay for me. You with me? I just got to get in. Costs $6 to get in the club. How much money do I have to bring so I know I can get in? $2. Because if somebody's going to give me 4, everything that I can do has to be 4 less than it used to be. I need this to make sense because this, on the surface of this, it can be really confusing to students. Because I don't blame you if you're sitting there like, math boy, is this plus 4 with the shitter? Why are we going? Since it is giving me 4, everything can be 4 less. I think I beat that to death. So if it's in with the x, it's left and right. Why does that make sense? What does the x-axis move? Left and right. Doesn't the x-axis go left and right? Okay, so if it's in with the x, it's going to be left and right, and it's going to do the opposite of what it looks like. If it's outside, I could put that with the y, couldn't I? Couldn't I subtract 2 and put it with the y? So if it's outside, it's y, it's up and down. Inside, left and right. Outside, up and down. How are we doing so far? And you can see the logic there. It's a nice way to remember it, but you can kind of see why that's true. Now what happened here? Yeah, it should have ended up looking like this, yes? Yeah. Oh yeah. Because what 2 things? That would make it go left 3, and that would make it go down 1. So now you start to understand, and I wish I wore that shirt on Monday, so it's dirty, I'm sorry, but I have the shirt with the little people dancing. Have I worn this shirt for you? It's got the little people dancing with all the different shapes of functions. And you're like, dude, I don't look at you. All right. If you know the shape of a function, all you have to do is graph the base function and then move it. You don't have to make an XY table. Yes, that's what this is really, that's the first level of what this is about. Okay, and by the way, notice this. This is outside. What did I say about inside versus outside? What is outside control? So up and down, yes? So how did this one flip? Up and down. If this is inside with the X, left and right, how did this one flip? Left and right. Do you guys see that? Thank the gods, it stays consistent. Yes? Okay, maybe. So I don't think everybody quite got to the last 3, but let's see. How many shifts are down here? How many transformations? Let me see if you guys see the transformations. It's a different function now, correct? But what would this make it do? That would make it go right 1. You with me? Because it's inside with the X, that's left and right, and it does the opposite of what it looks like, because all my inputs can be have to be 1 bigger than they used to be. Because the first thing this thing does is it takes 1 away. That's the mugger that takes $1 away from you. So everybody with me? So I go right 1, and then I would go down 5. So I have a parabola, that's what y equals x squared looks like, and I'll move it right 1, down 5. That's awesome. So you don't have to make a whole XY table and bullshit. Okay, maybe? So this would be right 1, down 5. What would this do? How many shifts are there, transformations? How many? More than 2. 3. There's this one, and this one. So what would order operations, and by the way, if you know this idea, you don't have to always do it perfectly in PEMDAS order, but to stay safe, you do it in PEMDAS order. Which shift would be first in the order of PEMDAS? Left 4, because that's the inside, right? We would do the inside first. So I would do left 4. What would come next? Yes, reflection would come next, because the last dude is the ass end of PEMDAS. So the next thing would be reflect around what? Or you could even just say reflect up and down or left and right. How would I move? Up and down or left and right? Up and down, so that would be x-axis, right? Up and down, I would rotate around the x-axis. And then, this would make it go up 1, yes. Now very quickly, side note, does anyone know what the absolute value function looks like? Just y equals the absolute value of x. Sorry. In the corner of my eye, I thought you were doing this, and I'm like, oh, this guy good. He's doing. So absolute value looks like this. And why does that make sense? Y equals x is a line like this, yes? So here's, yay, then it hits 0, and then it goes negative. Absolute value of x, can it go negative? So it hits 0 and it goes, oh shit! But it just changes all the negative inputs to positive outputs, so it just does this hard turn. This is the plane that you don't want to be on, because that turn, nobody's surviving. Thank you for choosing, bah! You're all dead off to the turn. I would rather be on the parabolic plane, that's better. Okay. So this looks like this, and then I would shift it left 4, I would reflect it, so now it's going to open down, and then I'll go up 1. So it end up looking like that. And let's see, how do I graph absolute values? This calculator's going to drive me crazy. Okay. Does anyone know how to access absolute value on this crazy expensive calculator? The math button. That should have intrigued you. If you've never seen a graphing calculator, the fact there's a button called math. And you're like, if I push that button, is my calculator going to explode with math? So if I hit the math button, the very first thing I see is interesting. That's interesting. Somehow fractions, right? But if I go over to number, do you see absolute value? So for example, if I go to y equals, and then I hit math, number, absolute value, chef. Let me try it. If I hit math, number, absolute value, and then I could put x. When I graph it, there it is. Yay! It's a V. PCAS. Okay. So, absolute value of x turns for the same reason y equals x squared turns. They can't be negative. But y equals x squared is curvy because it's a power higher, different than 1. Absolute value of x, the power is 1, so it's going to be linear. And that's why it makes this hard term. Okay. All right, that was a total side note, but we'll be fine. What about this guy? How many shifts do you see? How many? 2, good. What are they? What's the first one? Left 7, and then down 2. So whatever fifth root looks like. Does anyone know what a cube root looks like? Yes, I think so. Like the graph. Don't somebody do cube root there. The graph, right? So like a square root is this. A cube root is this and this. It can go both ways because it can handle negative inputs, yes? So any odd root looks like a radical with an extra one down here because it can handle negative inputs. Are you guys all with me? Even roots cannot handle negative inputs, they become imaginary. Odd roots are completely cool with negative inputs. Why? Because 4 negatives become positive, but 5 negatives stay negative. That's why. Okay. So I want to say one more specific thing about transformations. This is section 3.5, by the way. If I remember correctly. 3.5 is transformations. Transformations is just the general name for reflections and shifts up and down, left and right. And one more thing we haven't talked about yet. So let's look at square root of x again. This is a good one for this. So that looks like 0, 0, 1, 1, 4, 2. I'm going to do it dotted just because I'm weird. What would this do you think? It's obviously not in the root. It's a coefficient, yes? Can you see the old function there? There it is. So what does this do to the old outputs? Literally, what's it do? It takes the old outputs and it doubles them. Yes. So here's what's going to happen then. Like, what's the output at 0? The original, 0. If I double it, 0. What's the output at 1? Originally, 1. If I double it, double 1. What's double 1? What's 1 times 2? A double 1. Not square 1, double 1. You're still looking like I'm crazy. Take 1 times 2. What do I get? Okay. So here, the output at 2 is 4 is 2. If I double it, so can somebody describe to me without using the word double or multiply by 2, what did somebody reach in and do? If you could reach in and grab the original function, what would you do to make it become the new one?
Change the slope.
Okay, cool. Change the slope. Does everybody agree that the slope here is different? Well, what did I really do? Stretched it. It's a vertical, a vertical stretch. I stretched it vertically, right? What would happen if I put a 1/2 out front?
Probably get half.
Everything is going to have, so that would be what's called a compression. I would smoosh it. I actually call it smooshing it. The technical term is compression. This would be stretching it like taffy. Yes. Why are we going up and down? Compress it, stretch it. Why is it all happening up and down?
Outside of.
The 2 is outside. If it's in with the x, what direction does things happen? Left and right. Everybody with me? I love you guys. You're doing good. So if I had this, let me redraw this. Here's the original. By the way, this is how you do these problems. If they ask you to use transformations, you draw the base function with a dotted line, because that's not your answer, and then you apply the transformations. Now, let me help you look at this. This is so weird. Can anyone guess what this is going to do? Okay, there's a guess. There's a guess. It's definitely left and right, correct? So you could imagine it's going to stretch it, but no. What did x plus 1 inside do? Did it do the opposite of what it looked like? Same thing here. Now, why the shit, Jeff? Why does that happen? I really want you guys with me. What did I put into the original? What would I put into the original? What would I put in here to get a 2 out? What input would give me a 2 output? 4. What input would give me a 2 output here? 2! Isn't that half as big? So since somebody's doubling my inputs, all my inputs can be half as big. I need this to make sense. So I'm actually going to compress this way. I'm literally going to go, yeah. Now if I do that, what's going to happen to this? Can you guys imagine? Do I have anything that's going to work the way I want it to? No. Nah. So if I have something and I smush it, isn't it going to like bulge up? You guys kind of with me? If I smush it, it's going to bulge up. Let's see. It used to go to 2 at 4. Now I cut my x in half. When does it go to 2 now? 2. At 2. It used to go to 1 at 1. When does it go to 1 now? Cut it in half. A half. Do you see how that's smushing it back? And as I smush it, it's going to curl up. It's going to wrinkle up. Yes? Okay, maybe. Maybe? Maybe? Okay. Yeah, so if I have this and I push it back, it's going to curl up. Yes, it's going to curl up. Gotta have something. Okay, hopefully you guys are with me. This follows with what I said earlier. If it's in with the x, it's left and right, and it does the opposite of what it looks like. It looks like it should double everything. It actually cuts everything in half because it's inside. Go ahead, what's up?
You could use a piece of paper.
Oh yeah, thank you. I'm surrounded by paper. So yeah, if I have this and I smoosh it, there, can't beat that explanation. And that's exactly what happened. I smooshed it and went, okay. Stop for a minute. I love you guys. What I'm about to say is a little trippy, so it's okay if you don't get it. You don't have to look at it this way. It's just an interesting side note. Doesn't this look like a stretch up? Does anyone see that? Doesn't it look like a stretch up? Because, dear God, don't ever do this shit. You don't have to. You don't have to. Couldn't I do this as the square root of 2 times the square root of x? Isn't this the same thing? What am I square rooting here? 2 and x. There. Is this in with the x? Is that inside with the x right now? No, it's outside. So that would be up and down. Since I can write this like this, that's why it looks like it's a stretch. Because I could write it like it's a stretch. Do you really have to understand everything I just said about this? No, you don't. It's a weird little side note. But if you were curious, why does it look like I stretched it a little bit? Because I can write it with that part outside, and that would be a stretch. Yes? Okay, maybe. Very trippy, but I can't stop myself. It's kind of cool. All right. We got one more. Yeah, perfect. Okay. So that is section 3.5. 3.5 is all about graph the base function, list the transformations, use the transformations to graph the answer. It's a really cool thing. I can check my work when I do this. What point is this? What's that point? 2, 2. And I got that from just moving this back, right? Because I had to cut this in half. You guys with me? So I got that point purely visually. But since this goes through the point 2, 2, what has to happen here? When I plug in a, what's the input for this point? What's the input for this point? 2. When I plug in a 2, I'm supposed to get a 2 out. And sure enough, what's the square root of 2 times 2? Square root of 4 is 2. So when I plug a 2 in, do I get a 2 out?
Yeah.
So whenever you apply, what was another one we did? Whenever you apply transformations, did we really do one? Not really. Whenever you apply transformations, whatever new point you go through, plug it in. It's supposed to work in the equation now. Whatever points the graph goes through has to work in the function. That's why they're there in the first place. Okay. It's a way to check yourself. It's a really good way. When you're on a test, you want a way to check yourself. All right. So that was section 3.5. I'm going to talk a little bit about section 5.1. Stop doing that. Can anyone? No, you're good. I was gonna say, if you want to, you go back to your seats. I don't know if you're okay where you are. You can stay. Can somebody remind me? Do you guys know what that looks like? If I graph it, yes. 0 squared is 0. What's 1 squared? What's negative 1 squared? Stop. What's negative 1 squared? 1. So there's that shape, yes? Does anyone remember what this thing right there is called on that parabola? Vertex. A slightly better thing to call it, to be honest, is the turning point. But vertex is the official name, yes? But do you see how turning point actually makes a little more sense? It's the point where it turns. Okay. But not turning point USA. Good. Thank you. Do you know about it? So the vertex at the moment is what? What's the vertex?
0.
No, can't be because it's a point. What's the vertex? 0, 0. Is everybody with me? What happens if I do this? What shifts just happened to my squared? How did I shift it? How did I move it? Like to move
Down 4 left.
Yes, left 1, down 4, yes? Can anyone tell me without graphing, where's the vertex?
-1, -1.
-1, -4. I need you to see this. The vertex starts at 0, 0, correct? This would make it go left 1, down 4, yes? So the vertex would go left 1, down 4. Just to make a complete shift, watch this. This point would go left 1, down 4. This point would go left 1, down 4. And then I just redraw it, pretending like I did this well. My scale sucked. Where's the vertex now? Like you said, -1, -4, yes? You guys at all with me? Do you guys see I didn't need to graph the damn thing? I didn't need to graph it. I can see it's at -1, -4. Since it starts at 0, 0, the vertex just becomes a little shortcut of what the transformations are. it starts at 0, 0. So if I go back 2, then I'll be -2. If I go down 3, now I'm at -3. It just kind of captures what the movements are. So can somebody tell me where the vertex is for this? See if anybody overthinks it. So I'm not asking about the shifts, not about the transforms. What's the vertex? That's all I want to know is what's the vertex? Do it again. -11. Because what would this do? Move it back 11. And up 12. So did this change that at all? What's the only thing that would do? That would flip it. So now it's opening down, yes?
Now it's going down.
And that would make it really skinny. It would make it really go down fast. Yeah, it would stretch it, right? You guys with me? That has nothing to do with what the vertex is, because it just cares how much it moved left and right, how much it moved up and down. Okay, maybe. And also, now you know how to answer the question, does it open up or down? If it's positive, it opens up. If it's negative, it opens up. So will this be a maximum or a minimum point? Because it opens down, it's going to be the top of the hill, yes? So if it opens up, it's a min. If it opens down, it's a max. Because it opens down. Okay, whatever it looks like. It doesn't look like that, but I'll be right. So let's do this. Okay. Sure, we'll do something that's not too crazy. Sure, I like it. Take a minute, figure out what the vertex is, figure out if it opens up or down. It should just take you 20 seconds at most, right? What's the vertex? Does it open up or down? Don't say anything. Okay, who's got it? What's the vertex? 2? Negative 3. Good. And then does it open up or down? So will this be a max or a min? Yeah. Now let's actually graph this damn thing. I know the vertex, but if I just graph that point and I know it opens up, I don't know how to draw it. I don't know what shape it should have. Should it look like this? Should it look like this? Should it look like a satellite dish or a champagne glass? I don't know. Can you guys help me get the x-intercept? Not the x-intercept. Let's go y-intercept. X-intercept would be a little bit gross. Can you get the y-intercept for me? Does anyone remember how to get the y-intercept? Set what equal to what? No. No, I'm sorry. Yes. I went back to my first question. So I'm going to set, whenever I want the blank intercept, I make all the other letters 0. So if I want the y-intercept, I'm going to make the x 0. What do you get if you make the x 0? This is where good old order operations really kick some of us in the ass, so we gotta be careful. 0 minus 2 is negative 2 squared is, times 2 is, minus 3 is, yeah. So I know the y-intercept is 0, 5. So let's see what we got. I know the y-intercept is 0, 5. I know the vertex is 2, -3. Now, let's see if you guys are really cool with this. This point is special because it's where it turns. Would you guys agree that parabolas have symmetry? Meaning, if it's a parabola and this side becomes narrow, this side also has to. It's got to stay symmetric. Is everybody with me? So this is such a cool idea. First question I have for you, where's the mirror in a parabola? Where's the mirror? Straight down through the vertex, right? Straight down through the vertex, yes? That's the mirror. So if that's the mirror, where is the reflection point for this guy? Where's the reflection point for this guy? How far from the mirror is he? 2 steps away, yes? So then where's the reflection? 2 more steps in, right? 2 from the mirror on the other side. That's how far the dude is, or the dudette that you see in the mirror in the bathroom. You're like, who's that person? They're just pointing at you. You're like, stop pointing at me. Okay. I have a fight with that person. So I need you to understand. I need you to understand. This kicks so much ass. Y-intercept is easy to get. I make x 0. Vertex, as long as it's in the form that I gave, that's easy. So of course we're going to talk about what if it isn't in that form. Oh shit. And then I get a third point by just symmetry. I just get a third point because of the mirror image. And now I know exactly what this looks like. You can make whatever sounds you want to. Okay. And just, can somebody tell me if I would have made that a 1/2, what would have happened to the picture? It would have gotten wider, yes. Because that would have been a compression. So it would get wider. It would rise slower because it's related to the slope, kick ass. Okay, does any of this sound familiar to anybody? Do you feel like you've seen this before in any degree? If not, it's making a little tiny bit of sense. Like this much sense? No? Screw you, Jeff. So here, am I ready for this one? No. Okay. Last idea for the day. But it's a little involved, so I'm not get too excited. So everybody got all this business? Okay. So do you all agree then, if I have something in this form, it kicks so much ass. Now this one, I don't know if this freaks anybody out. I just put something up there that's got no numbers in it. But I'm going to ask you an evil question. What's the vertex of this? You can do it. What's the vertex of this? HK. HK. Why can you not tell if it opens up or down? Yeah, what would have to happen for it to open up? If A is greater than 0, opens down if A is less. That's crazy. It's crazy, Jeff. If it's in this form, I know a lot of shit about it, yes? Just like if a line is in the form y equals mx plus b, I know a lot of shit about it. So this idea of if I put the equation in a certain form, aspects of this graph just jump out at me. That happens all the time. Later this semester, we're going to talk about circles. If I put a circle equation in the right form, what 2 things are the most important things about a circle? What's like a physical dimension of the circle? The radius is important, but the radius is how far from the what? Center. So the center is important, and the radius is important. So mathematically, if I have the equation of a circle, if I put it in a certain form, I can see the center, and I can see the radius, just like I can see mx plus b. So this idea of like solving an equation for a certain form happens so many times. And of course it does, because where does the graph come from? The stupid equation. So whatever's going on in the graph has got to come from shit from the equation. Okay. Now, what if I give you something That is not in that form. Do you agree with me that's not in that form? Why is it not in that form? And I'm curious what kind of answers to get, because that's a very open question. Why is h of x not in the form of g of x? Okay. I think you're saying they're already like multiplied times? I'm not sure. Does the g of x have like a 4x term, like an x term by itself? Aren't all the x stuff in like one package?
Yeah.
Do we have a process to take x shit and make it become something squared? Completing the square. You're all like, alright. Is everybody cool with that? I cannot see the vertex here. I can't. I can't see, now I can tell if it's opening up or down. Which way is it opening? Because this is positive here, yes? Okay, so watch this. This is gonna, let's see if you guys are cool with this. Everything is gonna happen on one side because they really only have one side. So the first thing we're gonna do is make some room. And now I want to figure out what to add here. There's going to be an issue though, because I only have one side. But let's see if we can work with it when it happens. What are the steps to figure out what goes there?
Half of 4.
Yeah, half of 4, because the first number is a 1, so I'm good there. What's half of 4? Holy shit. And then I take that number and I square it. So now, I really want this to make nothing but sense. That side is not really a side. You guys agree with me? That's just h of x equals. So I'm going to work on one side. There is a way to do it, and I don't care, because you have to know the skill I'm about to tell you anyway. If I add 4 here, did I just make this side bigger than it used to be? If I add 4, is this side bigger than it used to be?
Yeah.
So what do I have to do at the same time so I don't actually change the problem? If I add 4, if at the same time I do what? Overall, I did nothing.
Add a minus.
Subtract 4. Now, on one level, that's dumb as shit. If you're like, okay, I owe you $10, can you add 4 and then subtract 4 from that? Done. Right? So it's kind of dumb. You'll hear it's like, oh, math boy, you did nothing. But is everybody cool with this? Doesn't this become this again?
Yeah.
Same problem, just looks worse, but can you factor this? That's the completing the square part, right?
X
So of course I can factor this. And what do I get out here?
minus 5.
All right, now can you tell me what the vertex is?
Negative 2. Yeah.
-2, -5, right?
Okay.
I like that one actually. If you say so. Just more stuff for us to do. All right, so the vertex, -2, -5. All right, last problem for the day, and then I'll let you guys out. Yes, sir.
-2, -5?
I'm sorry.
Be +2?
No, it's -2 all day. Why? How would this shift? Which way would it go?
Oh, right.
Yeah, good. Yeah, I don't blame you, dude. That's the same because it does take it down 5. That's the opposite because it's inside. It
Yeah.
kind of sucks. I agree. Okay, here's where things get trippy. You're like, now they get trippy. What did I just do? Okay, we'll do that. I'll do, yeah, I'll do 24. Yeah, I like it. Minus 10. No, minus 11. Hee hee. 4x squared minus 24x minus 11. So So the instructions would say, put it into vertex form. And the only way you can do that directly is by completing the square. First thing I'm going to do is I'm going to move the 11 over a little bit, make some room, right? Now, what is wrong with what's there? Why can't I use completed square immediately? Yeah, I've got a 4 in front, correct? I don't really have two sides. I can't divide f by 4. So instead, what I'm going to do is I'm just going to take it out. How are we doing so far? I'm going to say something really weird. You're like, yeah, you do all the time, Jeff. You don't have to say it ahead of time. Is there a 6 in this equation? Is there a negative 6 in this equation to begin with? So this is not negative 6. Do you agree with me? This is negative 24, correct? So whatever number's here, that's not what it is because it's multiplied by 4. This is not 1. 4 times 1 is 4, yes? Okay. Inside, is this a relatively easy completed square? Forget about them, forget about him. Just look on the inside. Yes, half of negative 6 is negative 3 squared is 9. And we've done this one enough, maybe you guys remember. So now, if I put plus 9, I did not just add 9. I didn't. I did not just add 9. The same way that's not 6, the same way that's not 1. What did I actually just do? I added 36. Do you see that? If I multiply that by, then I would be adding 36 here. So at the same time, what do I have to do over here? That is very confusing to some people, but I hope you guys see it's not that big of a deal. That's not really 6, this is 24. That's not really a 9, it's a 36, so I better take it away. So overall, what did I just do? Nothing. I just did nothing. What I really did though was I reorganized this. Can you factor this now? How does it factor? And what do I get outside? So what's the vertex? Is that cool? Does it open up or down? So this is going to be a max or a min? Minimum. Can somebody tell me what the y-intercept is? What would you have to do to get the y-intercept? You can do it. What do you have to do to get the y-intercept? Make x 0, yes? I don't want to do it here though. Yes. This is the same thing. This is the part students seem to kind of not realize. This function is the same as that function. They are the same. This just looks different. So if I ask you for the y-intercept and I got this, make x 0, I get negative 11. So the y-intercept is 0, negative 11. Dear God, don't use this if you don't have to. Right? Maybe. Maybe. How's that? Anything? Any questions on that? Okay. So don't get too used to this. I'm going to let us out a little early, just because I'm tired. So, tomorrow I'm going to have the practice test. You remember that was our first test? Next Wednesday. So what's happening next Tuesday? Review. I'll have the answer key to the practice test I'm going to give you tomorrow. And we'll only review for the test on next Tuesday. So tomorrow.
Do we take the practice test with us?
Yeah, like I said, you could throw it away if you want to. Recycle it. I don't care, because I'm going to give you the answer key, so I don't turn it into me. You with me? So you are going to take it with you. It's going to be yours. So you can do with it as you want. Yes?
So which chapter did it finish?